seats. My name is Jonathan Boror, or JBO for short, which is apparently also a German band. Yep. I work for Microsoft, and actually I prepared a Who Am I slide, so let's just jump right into it. That's me when I'm young and full of life. JBO, as I said, you can follow me on Twitter if you like. I'm the research architect for Microsoft Defender for Endpoint, which is like a very long title. But I mostly work on cross-platform, which is the Microsoft terminology for everything that does not run Windows. So I work on Linux, macOS, iOS, Android, Chrome OS. I do IoT or OT on Windows here and there too. I have a mix of offensive and defensive security. I'm a husband, a father, and a cat lover in that order. Some research motivation. Today we're going to talk about macOS. By the way, this is why it's in red. Some research motivation. As defenders, it's always important to challenge ourselves by testing novel techniques. And there's nothing more novel and noble than finding 0 days and testing them against ourselves. And basically, that's like the research motivation that I always have for offensive security internally. And every time what we did is decided to take one macOS security boundary and try to break it for the betterment of our products, right? So we learn the patterns, learn how like attackers might think, and try to detect those things and be more prepared for next time someone does something similar. And if you think about it, to achieve an end-to-end modern attack scenario, let's say on a macOS, you need several bypasses because macOS is full of defense in-depth mechanisms. I won't go into all of these technologies, but basically you need those things in some form of or another to achieve, let's say, an end-to-end attack. And I want to talk about the elephant in the room because I always get this question. Why does Microsoft find non-Windows bugs? I mean, and this is usually my response, like other people do it, so why not? But mostly I think that we have customers, and some of our customers run Mac and Linux and all of those things, and we like to protect them as Microsoft Defender. Note that I said Microsoft Defender, not Windows Defender. So we need to learn all of those things and all of those new technologies and operating systems. So just if you ever ask me those questions, just remember this meme and also remember my more mature response, I guess. I did say that that you need to, for an end-to-end attack. Let's say if you imagine an end-to-end attack on Windows, let's say, even today, sadly, you might start from malicious document with some macro and then jump outside that macro and hopefully move to, let's say, from medium IL to high IL or system or something, and then run some rootkit if you feel lucky. And on Mac, you want to do, let's say, if you want to do the same thing, then you need like a sandbox escape to escape the sandbox in Word specifically. And then after you gain arbitrary code execution, you might want to, I don't know, like capture like microphone or get access to certain files. So you might need to bypass a mechanism called TCC. And then if you want to, let's say, load the kernel drivers or do anything that's like more rootkitty, then you need something called a SIP bypass. I won't talk about those things just to give like a more general context. And one of the other entry methods on any operating system, but notably on Windows and Mac, is like fake apps and fake programs. And this is what I like to talk about today. And apparently you do need another vulnerability, and that vulnerability is bypassing Gatekeeper. Now, what's Gatekeeper really? Gatekeeper is a security mechanism that enforces code signing and download verifications. So initially, let's say, if you get something that looks like this My Resume thing, most of you would double click it, or I don't know if most of you, but let's say if you expect a resume, you probably double click the thing. And basically that might be malware. And you have like the layman at least has no way of knowing because, interestingly enough, it might be myresume.app, but the macOS UI actually hides, always, by the way, the .app extension. And you can choose your icon and whatnot. And this is how malware might spread. To combat this, what what Apple has done is basically enforce a mechanism called Gatekeeper. And what really happens is that the downloader, let's say Safari or Thunderbird or whatever you guys use, when it downloads, it uses a specific API. It doesn't just like read a stream of bytes and write them to the disk. They use a specific API, and that API also assigns an extended attribute called com_apple_quarantine. And that basically extended attribute kind of persists with the file on disk and kind of tells macOS, hey, next time someone tries to run me, do some verification or do some checking. And just for completeness, by the way, not everyone uses that API. For example, if you use CURL to download stuff, it doesn't use that API. And because of that, downloading with CURL bypasses Gatekeeper by default. But that doesn't constitute as a Gatekeeper bypass for obvious reasons. And I will actually talk about what a Gatekeeper bypass really is. But the format, in any case, the format of the extended attribute, because it's not just a label, it can also contain data, is the flag, ;date, ;agent name, and ;UUID. And it looks like this. If I try to download a fake calculator and double click it, it'll say calculator cannot be opened because it's from an unidentified developer. That's Gatekeeper in action. Note something very interesting. There is no ignore option. Like you can't say, oh, I trust this, run this anyway. Apple is like not letting you do anything here. And if you look at the extended attribute, I use the xatter utility -l to list all the extended attributes. You'll see that it says com_apple_quarantine. The 83 hexabyte, hexa there is like the flags, which I don't remember by heart, but basically means I'm like, check this, please. The next part is like the date time. Safari is the downloader, and then I promised the UUID. So Microsoft are not the only ones that use GUIDs. Just for completeness, this is really like a bit out of scope, but just for completeness, why do we keep a UUID? Because basically, like all of the information is already in the extended attribute. The UUID is used to identify entries in a SQLite database called Quarantine Events v2, which, by the way, is now broken on the newest Ventura. But like 2 weeks ago, this was still true. And then basically this database contains more information about the URL, origin, and stuff like that. I don't know why they duplicated data, but they did. And there is another database called VARDB system policy that maintains Gatekeeper exceptions, including whitelists and blacklists. And some of the whitelists also are loadable, are in some loadable bundles, and it's really quite interesting. And when I started looking at Gatekeeper bypasses, obviously one of the first things that I started looking at is the whitelist option. So if any one of you is interested in Gatekeeper bypasses, try to look at the whitelists there. One of the interesting things is that the whitelists are not are identified basically by hashes of the binaries or the app bundles, or the info.plist in the app bundles. And interestingly enough, you can change they can modify the algorithm if some of those things are MD5s, which is not great. But I couldn't really exploit it because I needed a chosen prefix hash collision to really exploit a whitelist in this case. So I kind of gave up. I don't have enough compute power. Anyway, there is an excellent blog post by one of our researchers, Shubham Dubey, on those mechanisms and many more. Feel free to check them out. Anyway, I do want to talk about Gatekeeper in greater detail. Before Catalina, before the OS build, Gatekeeper would check that the app is signed with an Apple signer, and that's pretty much Apple Developer ID, and that's pretty much it. If it's signed, then it would say yes or no. It will let you choose whether you want to run it or not. Otherwise, it would just prevent you from running it. But after Catalina, a new mechanism called notarization also started to get enforced, and notarization is Apple's final stamp of approval or final seal of approval on the app itself. Not only do you have to pay $100 to get an Apple app developer ID and basically sign the app and everything, you also have to have Apple sign it one more time to make sure that it's not malware, it doesn't look bad. They also enforce that the app is compiled with hardened runtime flags and other interesting things. So notarization like is also a thing now. So you have to basically like also pass kind of like a scrutiny by Apple, I guess, which is automatic. And that happened, by the way, because malware authors started like paying $100 and basically like signing their apps and then spreading them. So it makes sense, I guess. Patrick Wardle, who's like a macOS, like one of the greatest macOS researchers out there, described that policy as draconian. And I kind of agree if you think about it. Imagine like the backward compatibility. Now, if you want to spread your app, like a legitimate app over like, I don't know, web or something, it's not enough to simply sign your app. You also have to go through notarization, which is like an entire can of worms. So that's not fun. I want to compare, I look at different operating systems, and I said that I do Windows once in a while, and I do come from a Windows background, working Microsoft and all that. So I want to compare like apples to Windows, I guess. So it's pretty interesting, like the parallelism between COM Apple Quarantine and Mark of the Web. I see those as mentally, at least, as things that might be equivalent in some parallel universe. So the entry name for macOS is COM Apple Quarantine. On Windows, it's called Mark of the Web. COM Apple Quarantine is saved in like the local file system, APFS or AHFS plus, with extended attribute. And Mark of the Web is basically an alternate data stream. The enforcement, as we said, on macOS is code signing and notarization. And on Windows, it's Smart Screen, Application Guard, macro disabling on Office. And there is also a little quirk on Visual Studio projects. If you download them from the web and they have Mark of the Web, they like Visual Studio will behave differently. And there is also the metadata that is saved, which is a bit different, but you know. Anyway, when I try to look at vulnerabilities, I always like to learn my history. So I started looking at the like historical Gatekeeper bypasses, and interestingly enough, there are some of them, but not like tons of them. And there are two categories that I identified for Gatekeeper bypasses. One of them abuses, if you think about it, there are two main components. One of them assigns the extended attribute when you download the file, and the other one kind of tries to enforce policy once the extended attribute, after the extended attribute is already on disk on disk after the file was downloaded. So it has like two different steps, I guess. And there are two categories of Gatekeeper bypasses that I identified, at least. One of them abuses the component that saves the extended attribute, and the other one abuses the component that enforces policy on the quarantine files. So these are the two categories that I identified. It's noteworthy that some Gatekeeper bypasses have been used by malware before. Schleyer is an obvious one. And just to be clear, I want to talk about what a Gatekeeper bypass really is. And the point that I'm trying to make is that you cannot assume code execution, arbitrary code execution, and then say that you bypassed Gatekeeper. Like, for example, MITRE defines a Gatekeeper bypass as kind of deleting the external attribute. And that's kind of cheating, because if you already have like arbitrary code execution, like there's no point to it. So I won't be considering anything that has arbitrary code execution as a Gatekeeper bypass. And using an unsupported file system, a file system that does not support extended attributes, obviously, I also don't consider it like to be fair game. You won't be able to download something, let's say by default behavior, to a USB mass storage device or whatnot. So that's another thing that I won't be considering a Gatekeeper bypass. This is not a complete list by any means, but these are some interesting cases that kind of justify the two categories that I gave you. You don't have to read or remember all of those things, obviously, but I'll just give two examples. One of them is the second example here, the one that ends with 1810. It exploits it's like a type 1, Gatekeeper bypass, in the sense that it abuses the assignment of the quarantine attribute. It basically kind of makes the OS not assign the external attribute, because it was discovered that if the path was longer than 886 characters, like the external attribute can't be assigned. And they use like a symlink that points to an app that resides in a very long path. And that results in a Gatekeeper bypass, and that was pretty interesting to see. And just to see the other side of the coin, the third row here kind of talks about the other way, where the external attribute, ComApple quarantine external attribute was assigned, but basically the part that enforces syspolicd mostly has a bug that prevents proper enforcement of Gatekeeper, notarization, and all that fun stuff from being enforced, basically. So I hope that kind of justifies the two categories that I mentioned. So I was kind of inspired by the second one, specifically the one with the 886 characters. And I was like, I wonder if there are more cases where I can make the OS kind of not somehow assign an external attribute to a file. So obviously, like, Apple has fixed the thing with the long path quite well. And I'm like, I wonder if I can make more interesting things. So I try to create like big files and stuff like that, basically playing with a black box approach, and didn't work well. And at a certain point, I was like, okay, black box doesn't work. Let me just go like white box and start reading the thing. Now, macOS is pretty interesting because it's like semi-open source, I guess. Some parts are open source and some parts are closed source. It's pretty interesting. Specifically, XNU, the kernel is open source, and a lot of userland parts are also open source. And specifically, the part that sets an external attribute, I wanted to like check this function and see if it fails in some reason. And I didn't see an obvious way to fail that function, but I did see that they have a lot of interesting parsing and a lot of interesting operations that were like far from trivial. And I discovered a mechanism called AppleDouble, and that thing looked very, very, very interesting. So I started basically Googling or Binging. It depends on, yeah, I still say Googling. I started Googling the thing, and I'm like, what is AppleDouble? What is that thing? And apparently, the motivation behind it is that external attributes are common on file systems, but they behave very, very differently on different file systems. They might be implemented differently. And there are some file systems that simply don't support those things. And it makes sense to somehow, if you think about it, external attributes are like metadata of files. So it makes sense to keep that metadata somewhere if you want to pass files between different file systems. That's not surprising at all if you think about it. If you even work on Windows and you take like, I don't know, something that you downloaded with a mark of the web, and you copy it to a USB drive with FAT32 or something, that mark of the web like magically disappears. The reason for that is because FAT32 doesn't support alternate data stream, which is the way that Windows NTFS specifically maintains mark of the web. So the same thing happens on macOS, like HPFS, HFS Plus and APFS support extended attributes, but not all file systems support that. And they wanted like specifically to move to like network kind of file systems and maintain that data somehow. And then they came up in 1994, which is, some of you might have not been born even then. They came up in 1994 with a mechanism to save the metadata, right? And they came up with actually two mechanisms. One of them is to save the metadata in the file contents, known as an Apple single, or maintaining the metadata in a way that lives side by side next to the file. And that's called an AppleDouble for obvious reason, because you have two files, right? The file and the file that describes like other metadata. And it's distinguished by a prefix of ._. So also it's nice that on some like POSIX system, it might be a hidden file. And it has even an RFC, which is pretty interesting and not very long. Like you can read the RFC and like not go insane. So this is an example of how the thing behaves. In this example, and it's quite important. I know that it's a long text, but not really. It's important that you follow. So what I do here is I create a new file called some file, and then I show that it has no extended attributes. I do that with xattr-l, and then I write some extended attributes to it with the key attr key and value attr value, and assign that to some file. That works. Now what I do is use a tool called Ditto. Ditto is a tool that comes with macOS and basically is kind of like an archiving utility, I guess. And it has an interesting property that it can maintain create an AppleDouble, basically, maintain metadata. And you do that with a -K, if I remember correctly, or -C, one of them. And basically it'll put the sum file in a new zip file called sumfile.zip. So now that zip file basically has the sum file, which is basically an empty file, but might also have something else like the other metadata that I wrote, right? Then I remove the file, as you can see, rm sum file. And when I unzip the sumfile.zip, you'll see that I actually have two files that were extracted. One of them is sumfile, which is an empty file, and the other one is ._sumfile. That's the AppleDouble file. And if I try to look at it like in a hex editor, you'll see that it has a bunch of mumbo jumbo like binary data, and also like it actually has like in a readable way attr key and attr value. So this is kind of like shows a nice demonstration, like a toy demonstration of how AppleDouble is like created and kind of maintained. And that's like a pretty interesting thing to see. I mean, the binary data is interesting. Like I didn't know anything about it. So that's like a pretty cool thing to see. Now I started like analyzing, and basically you can read parts of it in the RFC, but the RFC is like much more generic than the code. Like the code is actually doing less. And I want to describe a bit about the format here, even though, we'll talk about it in a sec. In reality, the AppleDouble format could store like tons of data inside, really arbitrary data inside it. But in truth, really what happens is that Apple I guess they used that in the past to maintain some more metadata than I see today. But currently their code kind of expects a very specific structure of the AppleDouble file. And I want to talk about that just now. So the AppleDouble file starts with like a magic number and then a version. Version 2 is always what they expect for some reason. And then the number of entries. They simply validate that the number of entries is 2 always. Generally, the RFC allows whatever, but they only expect 2 entries, exactly 2 entries. And in this particular order, the first entry is entry number 9, which is finder info. They have like a nice enum for it. And all of those like headers will have like a type, offset, and length. So the type here is 9, which is finder info. The offset is 32 hexabytes from the beginning of the AppleDouble file, and the length is 64 hexabytes. Finder info, by the way, is not just a random name. That's how Apple kept finder metadata, if you're familiar a bit with macOS. So it's pretty interesting to see how they use those things. The second entry, they always expect entry type 2, which is a resource fork. And then you have the offset, which really in reality points to the end of the file, and then the length, which is 0. I don't know what that was supposed to, like, I know what a resource fork is based on what, like, reading the code, but they always expect the length of 0. I don't know why, but that's basically, if you look at their code, that's what they do. And now we start with the data. Like all of the data, as you could have seen, like the length itself was 0 for the resource fork. So from this point on, all of the data is really the finder info data. So it starts with tons of zeros, and then it might have some padding. Well, it will also have padding in this case. And then we get to the real meat of the file format, I guess. It starts with a magic that literally says ATTR in like ASCII. That's the green part here. And then debug tag, which I guess is used for debugging, but I looked at the code and never saw anything that uses it. And then the size, the data start, the data length, some reserved bytes, some flags that I didn't see any use of them either. And then the number of attributes. And the number of attributes is the number of extended attributes. This basically maintains the data about the extended attributes. And then basically you get like in this case, I only have one attribute, by the way. This is the number 1 here in kind of like brown, I guess. And then basically you have the contents of the attributes, which kind of contains an offset, a length again, flags, the name length, which is only 1 byte, and then the name itself, which is attr key. And then the data itself, by the way, which doesn't have to be, it could be binary data, which is kind of like the data itself, which is kind of like blue here. and data is attr value. That's basically how an AppleDouble looks like. And this got me thinking that copying files just got quite complicated, right? Because like, it's not just like taking a bunch of bytes and putting them in a different file system. It's not just read and write. Now you have to parse the AppleDouble file, which is kind of like a very interesting file format with tons of like offsets and many like interesting opportunities to basically screw up. And you have to like parse that file, validate that it's correct, and then assign arbitrary extended attributes to the new file. By the way, if the destination file system actually permits that kind of thing, which is also interesting. So copying files involves like quite a lot of operations now, quite a lot of logic. And this kind of explains what I saw earlier when I started looking at how set extended attribute API works. The good news about the file format is that it can be created by built-in utilities because I'm lazy. Like, I don't want to like start coding my own like AppleDouble creator. So you can use ditto and then unzip to create like an AppleDouble file with arbitrary, almost arbitrary external attributes. It contains the external attributes, keys, and values as they are. Like, there is no compression, no like encryption and whatnot. And there are no checksums or signatures, which is pretty cool because then I don't have to deal with like things that would slow me down. So, I mean, it's good news for me, I guess. This is another demo, like the other side of the coin, I guess. Here, I kind of showed you how to create an AppleDouble file. But in this case, I'm going to show you how to use an AppleDouble file and kind of like see how an AppleDouble file is being used to in a tiny experiment to show you how an extended attributes are created. So in this case, I put it under demo.zip, the sum file, and ._sum file. And then basically I remove those two files. This is the zip being created, and then I remove those files. Now I use open demo.zip. Open in macOS will open the default like app that handles .zip in this case, which is the archive utility, which is a full-fledged app which doesn't like, it has a UI, but like if you give it a file, it will actually extract it in the same folder silently without any user interaction. So that's pretty good. And then basically, if I look at the extended attributes of some file that was extracted, you'll see that I have attr key and attr value. This just shows you that you can use like AppleDouble files, and you can put them in a zip file, and when you unzip them, like those extended attributes will be assigned. By the way, they will only be assigned by the archive utility. If you try to use the unzip command, it won't work because it won't use that API specifically. It will just try to unzip those files, and you get the AppleDouble file extracted without the external attributes being assigned. So just FYI, if you try this at home. So that's pretty interesting, and note that like if you were unaware of what happens inside that zip file, note how like the external attributes kind of like appeared from thin air, and that's kind of interesting as a researcher, I think. So then I was like, okay, I have a new tool, I have a hammer, let's look for nails. My first attempt was kind of like, again, let's try to remember our goal. Our goal is to basically create, let's say, a zip file or some file. Oh, by the way, I didn't mention that, but when you download zip files on macOS, like by default, they will be automatically extracted in your downloads folder, which is even better for attackers. So let's try to remember our goal, really. Our goal was to prevent assignments of extended attributes to new file or files. If there is a limit to the number of entries, let's say, or the size of entries, and if those extended attributes get applied before the quarantine extended attribute flag, then we could probably use it, right? So this was basically my thought process. Can we create like a huge AppleDouble file with tons of data, kind of like fill up like a certain limit of number of extended attributes or the size of extended attributes, and basically like prevent the com apple quarantine flag extended attribute from being written? The answer is that kind of no. Because apparently if an AppleDouble is over 2 gigabytes worth of AppleDouble file, then it will be ignored. That's a first, it's not even 2 gigabytes, sorry. It's less than that. And then if the file is sufficiently large, then it will be ignored. And I didn't see any limit on the size of data or number of extended attributes. Like there are no limits there besides the disk size. So you can still use that, I guess. Like you can create kind of like a zip bump with like an AppleDouble file that kind of has tons of extended attributes in them. But from an attacker perspective, it's not that practical because you need to know the exact size of the how many bytes are left in the victim's disk in order to prevent that Apple quarantine file from being external attributes from being created. So that's kind of like fucked up, and I didn't want to do that. So I was like, okay, that's a failed approach. And then I had other failed attempts. I tried to create in the AppleDouble file, I was like, okay, let's create our own Apple quarantine external attribute in the AppleDouble file, and basically say like in the flags, as you saw in like the third slide, the flags were like 83. So I can find flags that say this app is good, but that was also a failure because apparently Safari just overrides the thing. So it was pretty interesting to see that Safari kind of, first of all, it will assign the external attributes to the file, and only then will it try to write like the Apple quarantine external attributes. So that kind of like was a failed attempt, but I learned a bit from that. And then I also tried to create like forbidden external attributes. One of the interesting external attributes that you could assign is Apple rootless, which will make a file basically undeletable because it will be protected by a mechanism called SIP, which I won't go into, but apparently the operating system doesn't like that and will just ignore that external attribute, which is good. I tried to fuzz the AppleDouble file format parser, and I did write a fuzzer. I didn't do an amazing job because I work from home and someone has to pay the electricity bill. But I did fuzz it for a while and didn't have like amazing results. So, and I also manually tried to look at the code, the parsing code, the open source part, and look for out of bound writes, reads, like integer overflows, all those things. And Apple did really an amazing job in making sure that the code is really secure. Like, I couldn't do it. Perhaps someone else could, but I didn't see any obvious things. And again, I ran my fuzzer for like a month. Didn't work well, and paid tons of electricity bill. So these were all failed attempts. And then I was like, okay, let's start reading the source code one more time, of the file copying function. And then I kind of discovered a special extended attribute name that if it's present in the AppleDouble file, it will set arbitrary ACLs on the file. And I was like, holy shit, that's pretty good. The extended attribute key name that you need to use is Apple ACL text. That's like their, I guess, secret sauce or something. And interestingly enough, you can't create that with a Ditto utility. Like you can as I kind of showed you earlier, like you can use the where was it? You can use the Ditto utility to create AppleDouble files with arbitrary, and I said almost arbitrary keys and values. If you had a key there that says Apple ACL text and try to use Ditto to create the AppleDouble file, it won't let you, like it will ignore it. I don't know why they did that. I want to believe that they didn't do it like as a defense mechanism. I thought that it was like pretty weird that it didn't let me do it. But I was like, okay, I can just like create an AppleDouble file and like patch the actual bytes inside. I mean, nothing will prevent me. Again, I hope that they didn't do it for defense purposes. If they did, that's kind of like silly. It's like, I don't know, relying on JavaScript client code to enforce input sanitization. It's not great. So, I mean, that didn't really stop me, just like a little setback. This is the actual code. You don't have to read everything here. But the interesting parts are here. First of all, it will basically, like, this part happens in a loop where it iterates like the AppleDouble extended attributes part. And it will look at the extended attribute entry name here. And if the entry name is this define right here, which is really Apple ACL text, that's the thing that I mentioned before, then it will go into this like if condition. And this if condition will basically like take the data, that's the data PTR here, call the function and remember that data PTR is like attacker controlled for what it's worth. They will call ACL from text, get an ACL, right? And if it succeeds, then basically it will set the ACL to the file. So that's pretty interesting, to me at least. I wanted to give a little bit of background on macOS ACLs, just in case you're unfamiliar. Normally, the way that permissions work, let's say in like Linux and whatnot, is that you basically have the files mode. That's like the, I guess, the basic kind of permissions that everyone is aware of, which looks like user group or other read, write, execute. And then ACLs are more like fine-grained access control. And they basically maintain a set of rules that are very much like firewall rules. The ordering does matter, by the way. And every rule is called an ACE, an access control entry. And this is quite, I think, like in Windows, you have something quite equivalent, I think. And you can view those things with ls and set those things with chmod. So just to show you an example, I have a file here called hello.sh. You can see that basically everyone is able to read from it. You see R and then R and then R again. And then I can actually view the file contents by using the cat command. And then I can do chmod plus A, that will set an ACL. And then I will write everyone deny read hello.sh. And then when I try to cat the file, when I try to print its content, it will basically tell me permissions denied, even though I'm supposed to be able to read the file because I have, again, R, R, and R. So everyone is basically supposed to be able to read the file. But because of the ACL, you're not able to read the file because the ACL, which can be viewed with ls-e flag, if you see that little plus sign here, it basically says that there is more information with the file, like with the file permissions. And that information is basically the ACL that says, everyone deny read, which is kind of what I assigned here. So again, kind of like another security mechanism on files and secureable objects in macOS. And there are like tons of different, well, not tons of them, but there's a finite list of ACE types and kind of a set of verbs in ACEs, and they're richer than the simple read, write, execute. So for example, here are a couple of them. This is not a complete list. Write utter controls the ability to write what they call basic attributes to the file. We won't go into that. Write ex utter controls the ability to write extended attributes to the file, which is kind of interesting. And some of you might also like get their browse up already. Write security controls the ability to set ACLs to the file. So it's pretty interesting. You can like create an ACL that prevents others from setting an ACL. Pretty neat. And there are other things like you can prevent or make someone, like you can control the ability for someone to like change the owner of the file or delete the file and whatnot. So all of those things are pretty interesting, I think, just if you were unfamiliar. And for me, at this point, I was like, I can, like the exploitation for me, it's trivial. I will save a very, very, very restrictive ACL in an AppleDouble file, zip it next to my fake app, like the myresume.app or whatever, and serve it on an HTTP server. And basically the hope that when Safari extracts the zip file, all of those like the restrictive ACL, which is described in the AppleDouble file, will be in effect, will be set on the extracted file. And then when Safari tries to write the com Apple quarantine external attribute, it will fail. Why? Because it can't write an external attribute because of the ACL. So that's basically the exploitation idea that I had. And I had one problem. It was to set the right text representation, like the external attribute data in the AppleDouble file. It's not the same format. It's not the exact same format that you use in chmod, but you can just, if you saw the code earlier, it calls like ACL from text. So apparently, like the other like inverse function of it is text to ACL. So I can basically ACL to text, I think. So you can use like the ACL to text API to create that data and basically like put it in the AppleDouble file and do whatever. And I chose the following ACL: everyone deny, write utter, write x utter, write security, and shown. I mean, that's basically what I did. And this is like I'm going to show you like a video of the exploiting effect. But this is essentially how it looks like. You create your evil.app or myresume.app, depending on your preference. Create an AppleDouble file with a very restrictive ACL, as I said. You combine those two together and put them in a zip file, and then you host them somewhere. When someone downloads the zip file, they will basically like extract, Safari will extract it automatically, by the way, to disk, and will then apply the ACLs. So now this evil.app has very restrictive ACLs, and then it will try to set the quarantine external attribute, which will fail. And then basically you have like a file, evil.app with no extended quarantine external attribute, which basically means that someone can just double click it and Gatekeeper will not be enforced. That's the entire idea. Let me actually try to play the movie. This is the demo, and I hope it's kind of tiny, but basically, I basically like prepared the thing. I called it Achilles, by the way, because it's the Achilles heel of macOS, and also I use ACLs, so why not? And then at this point, like I already serve it on like on my own like local host HTTP server, because why not? I download the zip. And if you, by the way, there is a reason which I will discuss in a sec why the zip wasn't automatically extracted. And then if I double click it, I basically get a Gatekeeper bypass. This was already code execution without any pop-ups. So, so that I think that was pretty cool. And this is the exploit that I have, by the way. It's pretty interesting because usually for exploits, you like write code, but this is the exploit. And when I mean by the exploit, I mean that this is the double apple file that you can always use and rename it to whatever you like and basically put it in a zip file. The same AppleDouble file, this same file. And you can see right here in the, you can see right here like all of the restrictive ACLs. ACEs in the very restrictive ACL. You can basically, this is called like ._myresume.app. You can call it tomorrow ._calculator.app or mywhatever.app with the same file contents, and it will just work. So it's like the exploit, if you will. Pretty interesting to release an exploit without any code, just data. So that's kind of like generic and cool. Bonus, lockdown mode. A few months before I found that thing, Apple has announced that they have a new thing called lockdown mode. It got it like a big security hype, justifiably, I think. And this happened a bit after forced entry, that's like NSO kind of thing. And that was mostly on iOS devices. The idea was basically to enter kind of like I don't know how to call it, like defensive mode, or should I just call it lockdown mode? Lockdown mode, and that's supposed to basically harden the system against zero-click exploits. And they basically say something like, if you find a way to bypass lockdown mode, like we'll pay you like $1 gazillion or something. I don't know how much. And I was like, and that thing, by the way, also the lockdown mode also is a feature on macOS Ventura, which is kind of like neat because you can protect your macOS as well. And I was like, okay, this thing bypasses like lockdown mode. By the way, the reason in the video why the zip file isn't automatically extracted is because I ran the entire video, the video that you saw 2 slides earlier. I ran the entire thing in lockdown mode. So my computer is supposed to be locked down, yet I was able to get like arbitrary code execution and bypass Gatekeeper. And Apple were like, some fine letters here. Something that this is not a 0-click exploit. It's supposed to be like a 1-click exploit. When they published the thing about lockdown mode, they didn't specifically write 0-click exploits, but I was like, okay, whatever. I don't care really. I'm not doing it for the money. So the point that I'm trying to make here is that this kind of bypass and many other bypasses, they work against a system that has lockdown mode on. And that kind of means that lockdown mode is no substitute to have your OS up to date. So even if you use lockdown mode and you're like a journalist and you're afraid of being hacked or something, like always try to update your OS, even if you're in lockdown mode. For detection is quite challenging, to be honest. And this is like for the like blue teams around here, it's quite challenging. Luckily, Apple has already fixed the thing, but again, I'm trying to be generic. So I talked about like the two different families of Gatekeeper bypasses, and basically, if you have an antivirus, you can just look for files with restrictive ACLs in AppleDouble files in an archive. Obviously, if you're like an EDR and try to like count on behavior, then I would probably look for downloaded or extracted contents without the quarantine flag being set. And this kind of like is a generic detection for all type 1 Gatekeeper bypasses. And I had another idea which kind of looks at the path that a freshly downloaded app runs in. Apparently, if it has like the Gatekeeper flags, it will first run in a directory called app translocation. It will not happen if you bypass Gatekeeper. So that's kind of like a neat way to detect it. Disclosure happened on July 27th, 2022. Apple fixed it like in September 2022 in their beta, and it was generally available in December. And again, thank you, Apple, for the fix. That was a very interesting fix. And they fixed that by simply preventing the specific feature of AppleDouble files in the archive utility. And my question or taunt is that, can we find similar bypasses? Not sure. We'll see. And with that, thank you so much. I will be taking questions. Thank you. Sorry that I took some time from the other speakers or lunch. Lunch. Sorry. Yeah.
Thanks for the talk. I have a question. Did you find a way to set forbidden flags, for example, using the AppleDouble file on a system which doesn't support extended attributes and then hoping that it gets parsed? So does it not get actually applied until some API calls the, set the attribute on APFS?
It's an interesting question. To be honest, I didn't, I tried to extract like those zip files with AppleDouble files on several other file systems that macOS supports, including like network and stuff like that. But I only did that from a black box perspective. I didn't see any effect. So probably they have a way to ask whether the file system supports it or not. They probably have just a list of file systems that can support extended attributes and basically behave accordingly. I didn't see anything interesting in that regard. It could be interesting to set the com apple rootless flag, but I didn't quite experiment with that. But it's a nice research avenue, I would say.
Thank you.
Thanks.
So we are running out of time, so thank you.
Thanks. Thank you.